Okay, hello everyone. Thank you for joining us today for this webinar in the middle of a busy week. My name is Masataka Okuno, the Senior Application Engineer, APAC Markforged. So in this webinar, I will be introducing how the Markforged can contribute to the food and beverage industry through the applications that have already been proven in the factories around the world. So before we start, let me ask you, what do you know about 3D printing? What exposure have you personally had? And what is your perception of 3D printing? So to clear up your mind first, I would like to start off from quickly playing a video to showcase the Markforged application spotlight for food and beverage industry. So let's get started. And also, sorry, forgot to mention, so if you have any questions during this webinars, please feel free to type in your questions in the Q&A box at the bottom of your screen. Thank you. Okay, so let's get started. Very cool video, huh? So there's a lot of misperception about 3D printing. So I would like to start off with a bit of context for the type of 3D printing we are talking about today. That is industrial 3D printing. So the 3D printing has been used by business for rapid prototyping for decades. The fast physical 3D model add immense value to the product development process, even though the models are not as robust. So you may already know that it has been widely adopted. And as the costs came down, the 3D printing has entered the consumer market at homes and maker spaces. And at the same time, 3D printing has also evolved in the opposite direction, becoming robust and reliable enough to be used in manufacturing. For parts that are needed quickly in small quantities on a production line, or that require some degree of customization, 3D printing is often faster and cheaper than an in-house machine shop or outsourcing. For examples of some applications that you have just seen in the video, end-of-arm tooling, something like the custom vacuum for pick and place, grippers, robotic welding shanks, and forming applications like sand casting patterns and sand core molds, or molds for thermoset resins, tube bending dies, and also the sheet metal dies. And measurement and inspection applications, check fixtures, gauges, or like CMM fixtures. replacement parts applications, so the digital inventory for the infrequently replaced parts or consumables, and replacing the old equipment that is no longer supported by OEMs. Ergonomic and safety aids and poker yoke, work holding, machine fixtures and soft jaws, assembly jigs, drill guides, welding fixtures. There are lots of applications already introduced to the manufacturing floor. So amazingly, analysis by Ford, Dana, and others suggests that 10 to 20% of these industrial parts can be used right off the print bed. But unfortunately, it's not as sexy as the mass production, means 3D printing the final part. So you don't hear it much. Many pundits or CEOs talking about it. But this is exactly the sweet spot for the industrial 3D printing today. Okay, so taking a closer look at the food and beverage in production, many of the most common applications of 3D printing occurs at the packaging stage. For example, again, vacuum grippers for pick and place for anything not standard off the shelf, perhaps the most common food and beverage applications of the 3D printing. Mechanical grippers, this can be composite or metal if the greater heat or abrasion resistance is needed. Pushers for conveyor lines, as well as the rollers, gears, gauges, sockets, or like O-rings. Bellows and belts and gaskets, these can be like soft parts. These soft parts can be printed from TPU. And safety guards and ergonomic aids are great for 3D printing because they can be designed to precisely fit the specific line layout. So as you know, the manufacturers have been making or purchasing these parts long before 3D printing arrived. So why have so many manufacturers already started to 3D print them instead? Because the ability of the 3D print production line parts can help solve some of the most significant business challenges for food and beverage manufacturers. These range from simple and certain cost reduction and supply chain optimization to strategic needs for manufacturing agility and workforce development. So any of these particularly relevant or not relevant to your company, or are there other important challenges for you today? So let's double click into each of these to explore exactly how 3D printing helps. We will use some real customer examples when possible, some from the food and beverage industries, and some from the other manufacturers. Okay. So let's get started with the Danone case study first. So the cost reduction is the most common reason food and beverage manufacturers turn to 3D printing. So this includes Danone, a global leader in nutrition, essential dairy, and plant-based products. So their Bieruń factory in Poland is Danone's leading production center in Europe, supporting both the domestic market and more than 20 other countries. Factories faced supply chain disruptions, limited availability of spare parts, and equipment maintenance issues. Now they are currently 3D printing the vacuum grippers, carton pushers, and pinions seen here in this slide, as well as the gears, head covers, rollers, conveyor connectors, dispenser clutches, and more. And the parts cost savings alone paid for itself in less than a year. Cost saving of 80% or more are common. Most shops see a payback period in less than a year from basic cost saving alone. Okay, next one. In addition to the reduced part cost, 3D printing also improves the performance of food and beverage equipment. Harvestance, a South Korean service provider for food and beverage and other industries, provides a typical example with the 3D printed vacuum grippers. Markforged unique continuous carbon fiber reinforced onyx composites brings the strength of the aluminum, but with the significant weight savings. As you know, lighter weight reduces costs and improves productivity in several ways. Like this harvestance gripper provides 10 to 15% greater lifting capacity for small 20 kg cobalt. Or manufacturers can run the equipment faster, or the manufacturers can get the same work done even with the cheaper equipment. So with the 3D printing, the vacuum channels can be built into the part, which means greater flexibility with movement and also eliminates the need to maintain the hoses. And delivery time, of course, it was reduced from 2 weeks to 2 days compared to the conventional CNC machine grippers. Okay, so do you utilize custom vacuum grippers in your facility? Probably you do. Okay, so 3D print can enable lots of cost savings in MRO by utilizing the digital inventory to store the common part that can be implemented across different sites all over the world. So the MRO usually accounts for 5 to 10% of a company's cost of goods sold. Typical manufacturers can use the 3D printing for 10 to 40% of their parts. As we showed just a minute ago, 3D printing can cut the cost to acquire many parts 80 to 95%. 3D printing reduces MRO cost in other ways also. So reduce the carrying cost of MRO inventory that is up to 12 to 30% of the purchase cost. Reducing the inventory obsolescence, which is usually about 15%. In the rare but costly occasions when you can't produce because you're waiting on replacement part, the faster turnaround 3D printing gives you is the priceless. The processing the magazine reported that the unplanned downtime can cost a food processing facility $30,000 per hour. It's huge. So print your own replacement parts after OEMs stop supplying them. Okay, so here's an easy to understand example of how eliminating the unplanned downtime on a food production line works to reduce the cost hugely. A part on the production line breaks, causing the line to stop operating completely. If it takes 15 days for replacement part to arrive, how much loss can you expect? So if a line with a production capacity of 48,000 kilo per day stops for 15 days, you can calculate the loss by multiplying the production capacity, the number of the days operation will be down, the unit price of the product, and the operating profit margins. So in this example on this slide, the loss is expected to be more than $1.2 million. Now you can already see how much cost saving can be achieved if 3D printed parts can reduce this downtime to less than a day, right? So in addition to reducing the cost, 3D printing helps manufacturers maintain and grow their business by meeting consumer demands. Most food and beverage markets are highly competitive. There are two key strategies for manufacturers: product and packaging innovation. Second, targeting smaller segments of consumer markets with the new products. So both of these strategies require more agile manufacturing and more versatile production that can adapt quickly and profitably in shorter time frames. Faster turnaround with the 3D printing not only reduces the cost of line down events, but also improves the top line ROI through the faster line setups and the changeovers. At one of the Sundry soft drink manufacturing factories, the company had to replace as many as 300 tubes to accommodate the wide variety of PET bottles designs. The frequency of these changes in the design of PET bottles and other packaging containers made it essential to improve work efficiency. So Suntree was able to reduce the cost of jigs production to less than 1/10 and the lead time to less than 1/20 by bringing the production of custom jigs in-house. And of course, this improved workability by these customized jigs has also cut the time required for setup and changeover by about half. The top consumer demands for the food and beverage industry is to reduce the environment impact. Consumer demands it, regulations is spreading, and some customers or retailers even now starting to impose fines, penalties, or cost disadvantages on producers in relation to sustainable packaging. So how much sustainability pressure does your business faces? So 3D printing helps in 4 ways, and 2 of them we've already mentioned. So reducing the transportation-related carbon. So printing the replacement parts on the factory floor instead of shipping them through the OEM supply chain. Think of kind of a locavore of manufacturing. On-demand printing the spare parts avoid the obsolete items up to 15%, which is an additional benefit to the MRO benefit explained above. And less material waste. Additive manufacturing create less waste than the subtractive manufacturing because it has only the material needed rather than cutting parts out of the large block of material. So according to a study in the Journal of Manufacturing Science and Engineering, additive manufacturing is now being used across multiple industries to reduce the material usage by 35 to 80%. The flexibility of 3D printing also allows for part consolidation, which works for further reducing material waste. Sustainable packaging. So often the sensitive materials are used and must accommodate more frequent changes. 73% of CPG and contract packaging respondents reported that material changes are occurring more frequently these days. And even now, on 24th of April 2024, last year, the European Parliament adopted new measures to make the packaging more sustainable and reduce packaging waste in the EU. For example, certain single-use plastic packaging types will be banned, starting off from the January 1st, 2030. But finally, the 3D printing can help manufacturers recruit, retain, and improve the health of their workforce. So attracting and retaining the talent in the top business is the top business challenge for the manufacturing for the 4th consecutive year, according to the National Association of Manufacturers Q1 2024 Outlook. So according to the US Chamber of the Commerce, as of August 2023, there are still more than 600,000 unfilled manufacturing jobs. 3D printing empowers new or less skilled workers to manufacture parts, freeing up your more experienced employees to focus on more challenging tasks. And this creates a more attractive and engaging workplace. Avenues for upskilling. The first strategies to address skills shortages. It also empowers manufacturing teams to solve the problems on their own. According to Grant Thornton, 19% of manufacturing employees cite job autonomy as a reason for changing jobs. Plus, giving your employees the opportunities to learn and master the latest manufacturing techniques will also create a more attractive employer's brand. 33% of manufacturing workers say that the opportunity for career advancement is the biggest motivation for searching for a job. And also 76% of Generation Z want opportunities to learn or practice new skills during their job search, making this a top priority, according to LinkedIn's Employees Wellbeing Report. A very direct way that the 3D printing helps your workforce is by keeping workers safe. So with the advantage cost of a workplace injury claim being $120,000, so preventing just one of these could recoup the cost of an industrial 3D printers many times over. So 3D printing makes it easy for teams to implement their own safety and ergonomic aids. So there are almost always customer designs specific to the facility and the line, and not needed in the large numbers, and this cannot be acquired from the third parties. So creating a safer work environment doesn't just save money, it also helps you retain the skilled workers. Work environment is a top driver of employee retention. Okay, so hopefully that gives you a sense of the ways 3D printing is helping our customers in the food and beverage industry tackle some of their business challenges. So which of those examples resonate with your business? Can you imagine other ways that 3D printing could help at your facility? So next, I want to dive into how the Markforged solution helps your businesses. Okay, so first, our platform, which we call the Digital Forge, is designed to support manufacturing, not prototyping or mass productions. So let's talk about our 3D printers first. So our industrial 3D printers are durable, reliable, and precise. The FX10, just you've seen in the video, is the first industrial metal and composite 3D printer, the product of years of engineering innovations and technological advancement, built on the success of the Markforged X7 and Metal X. FX10 is now quickly delivers the strong, accurate tools and fixtures to your factory floor. Next, the materials. So we offer metals and composites formulated for manufacturing applications. So our unique carbon fiber reinforcement provides the strength of metals with the simplicity of the composite printings. Third, the software. Our software is a core part of the solution, not an afterthought. So Eiger is the cloud-based software platform that powers Markforged 3D printers, and it's designed to make the entire 3D printing process from design to finished part as seamless and efficient as possible. So it's designed to get the parts printed quickly on the factory floor, not by experts tweaking the settings. So what matters most is how we tightly integrated these three pillars. Most of the 3D printing vendors have an open ecosystem, which puts the burden on you to make sure everything works well together. But our ecosystem is different. Our ecosystem is closed, similar to how Apple integrated the iPhone, iOS, and App Store to make it super easy for consumers to use. So this is the only way we can deliver the simplicity, consistency, and repeatability manufacturers demand. The Digital Forge makes it simple to create the strong parts anywhere and anytime, so the manufacturers keep the line running and produce right parts on the factory floor. Okay, and I believe now you have already understood from the explanation so far that the solution provided by Markforged are bringing the innovation to various manufacturing industries, including the food and beverage industry. But our solution will not stop. We are proud to introduce our new nano-white food safe material. Nano-white food safe is an unfilled, non-abrasive nylon that is certified by NSF to NSF ANSI Standard 51, which means the food equipment materials. And it is certified for food contact and is compliant with the FDA CFR Title 21. The introduction of this new nano-white food safe further expands the previously limited applicability of Markforged solution to the food and beverage industry. So companies that operate the food and beverage factories have the parts on their lines that needs to be compliant with the various rules and regulations. A common requirement for some parts, especially those that are in direct or direct contact with food or close proximity to food, is that they must be made from the materials that are approved for food contact. A lack of certified material limits the number of applications that can be addressed by additive manufacturing. For example, useful applications have tended to be limited to packaging stage, as explained earlier. So previously, the discussion with the food and beverage prospects often end early because we did not have a material that is certified for food contact. But now we do. The introduction of NSF certified nano-white food safe unlocks the full potential of Markforged applications such as 3D printing MRO parts to the pre-processing stage and also the processing stage where the parts come into the direct contact with food. The pre-processing stage, so this refers to the initial steps involved in preparing the raw materials for further processing. And this can include like cleaning, sorting, grading, and other preliminary treatments. And the processing stage, the raw materials are processed to create the final food food product. And this may involve the cooking, baking, fermenting, or other methods depending on the type of the food. So one of our major customers already estimates that adding the food contact material to our digital forge has doubled the number of the applications it can be addressed. And the key note here is that the nylon white food safe itself, the material itself is NSF certified for food contact, but the printed parts are not automatically considered safe for food contact. For any direct food contact applications, customers are always responsible for validating that printed parts meet their specific food safety standards and requirements. So if you have any concerns about this, please contact our Markforged sales teams anytime. Okay, who is nylon white food safe for? So nylon white food safe is an ideal material that offers a tremendous advantage to food and beverage factory floor support who create production tools and replacement parts to support manufacturing operations in food and beverage plants. Also, the nylon white food safe offer an advantage to food and beverage machine builders who design, produce, and integrate the low-volume machinery and automation systems for food and beverage factories. So both offer the same benefits, including the reduced MRO parts cost, shorter production time, improved workability, and empowering the employees. Okay, conclusion. So that's all from us today. So what did you think? So hopefully now you now discovered and have a better understanding of how the Markforged solution is transforming the food and beverage industry and can efficiently solve the challenges. As we explained throughout the webinar, the benefits that the food and beverage industry can enjoy from additive manufacturing are significant. And Markforged solutions bring these benefits to the factory floor even more efficiently, easily, widely, and simply. The Markforged applications are already proven in the factories around the world, accelerating the business by printing the part at point of need. So why not start applying it to your food and beverage manufacturing today and supercharge your production? Thank you very much. Happy printing. So yes, so let's move into Q&A sessions, if there are any. First questions. Okay. Are there any limitations to the amount of contact food can have with non-white food safe? So I guess it fully depends on the customer's own regulations or standards, and also the geometry of the part and also matters, because think about the surface finish of the printed parts. If the printed parts have the rough surface finish, those raw food will be trapped into those layer lines, and which will cause some bad contaminations or some bad results. So yeah, so as I explained during the session, the nylon white food safe material itself is the food safe, but the printed part has to be always be tested by customers by their own. Okay, so next questions. Will food safe nylon be reinforceable with Kevlar on the FX10? The simple answer is no. So yeah, so Markforged offers our unique continuous fiber reinforcement technologies, but adding the continuous fibers will change the properties of food safe material. That means it will not be certified that the food safe materials anymore if the continuous fiber is added inside the part. So not only the Kevlar, but any continuous fibers cannot be added to any direct food contact applications part. Okay, so does nylon white food safe print at the same speed as per Onyx? The printing speed itself would be very similar to Onyx, but it required some heating and cooling time. So in total, will be slightly longer than the Onyx. Okay, purchasing cost and the operating cost. So would it be the questions about the material cost of the nylon-white food safe? Okay, so if you're asking the material cost, please reach out to our Markforged sales team, and we can provide a quotation. Okay, so adding to the answers that I provided regarding the continuous fiber reinforcement to the nylon-white food safe. But if the application is not for the direct food contact, like the packaging stage, of course you can add the continuous fibers to Onyx or nylon-white. Okay, so it looks like there's no more questions coming in. So I will end up the session for now. But if you have any additional questions to ask, please reach out to us anytime, and we are always happy to answer your questions. Okay. Okay, thank you very much for joining this webinar again. Okay, happy printing. Thank you. Bye-bye.